Department of Computer Science and Engineering and IT is housed in this elegant building where we have various labs, state-of-the-art facility and classes. We have various research labs also. One of the key features of this department is we have faculty members who are well qualified, having experience in teaching as well as research. They have obtained their degrees from reputed organizations like IITs, NITs, as well as renowned foreign universities.
Graphic Era works very closely with industry. And after interacting with industry, we realized that industry does not want bookworms. Industry wants students who can deliver right at the industry. So in considering what industry needs, we designed our curriculum. Specifically, we have introduced two specializations. One, BTech in computer science with specialization in cloud computing. Another one, BTech in computer science with specialization in big data. Actually, what is this? Cloud computing, if you have seen 90s and 21st century, everyone talked about internet. So one day cloud will be that internet of coming years, where everyone will buy software services. Just like right now, you go to internet to download something or to upload your data. In future, let us say you want to run a program and the program actually takes a lot of hardware resources, or you do not have a software for it. Let's say there is some video editing program, but you do not have enough resources for it. You do not have the hardware and it requires a lot of resources. What you can do? You can purchase that resource, the hardware resource you can purchase over the internet. So you will upload your program, it will run on a remote site, and you will be just charged some particular amount for that. Imagine that kind of development which will come, everyone will be actually going for it. So cloud computing is a framework where software is given as a service rather than only services provided through internet.
We have set up our own private cloud, and this cloud is made as available to the students as well as researchers to do a research how to offer services. For example, the Google offers storage as a service, right? Most of the people use it as a service. However, you do not know what is happening behind the scene, what Google is doing. So we have set up that private cloud computing facility where the students are able to carry out their research about how to store data. And currently we are providing two services. One is infrastructure as a service, wherein the students as well as researchers as well as faculty members are able to get connected to a computing facility. They get a desktop on their mobiles or on their laptops, and the computation is performed on the cloud.
This is our cloud facility of our university campus. So as you can see, this is a Windows 7 operating on a cloud of our university campus. So you can do pretty much everything in this. You can store your data. We have attached storage to it. So you can do anything. You can run your softwares, pretty much everything that you do on your computer.
In addition to that, big data computing, in big data we have got enormous amount of data. Like for example, Facebook has got petabytes, that means 10 to the power 15 bytes of data uploaded every month. Now in that data, Facebook must mine many important things. So they require computer science engineers who can discover patterns, who can help people, who can actually increase the business in some manner.
Similarly, we have a cluster of Hadoop which stores big data. There is a lot of research going on in the area of storage of big data as well as big data analytics. So in order to carry out the work, you have to have a setup. So our university, our department has this setup where we have established a cluster of Hadoop HDFS file system, and in order to store the data, we are using HBase, which is used for storing semi-structured as well as non-structured data, which is difficult, which is not possible to be stored on conventional databases like RDBMS.
We have used Hadoop MapReduce for finding motion detection in video frames, and the size of data which we have processed using Hadoop, that is a cluster of 5 nodes, is 1 TB and we are able to reduce the computation time by 60%.
We have desktop supercomputer having the cores around 2888 cores in one machine. So it's an enormous amount of the computational power to the tune of around 4.5 teraflops, so which is huge. So how the computationally expensive applications can be parallelized and it can be harnessed.
So I make use of this supercomputer for my research for doing for parallelizing many content-based image retrieval algorithms. Normally the content-based image retrieval algorithms are computationally very expensive. So we use this supercomputer to parallelize it by making use of the 2880 CUDA cores which are available, which are massively parallel cores.
We also have the facility to analyze this data. Like for example, the Twitter data, right? How it can be stored and analyzed. Storing in itself is a challenge, and how efficiently it can be stored is one more challenge.
Here we have installed HBase in pseudo-distributed mode and use it to store a comma-separated values file containing Twitter data. That Twitter data contains tweets from NBA final game. Now we can extract the information easily, which was not possible when the data was in its raw form. We have used HBase over SQL because SQL does not provide any APIs to automate this task, but HBase, as it supports Java APIs, we were able to automate this task and utilize the resources optimally and store the data in an efficient way and extract as much information as we want.
Many parents and students come and ask me, can you suggest an area where you see that our child will have the best scope after 10 years or 20 years? And I would definitely say it is computer science, because the kind of growth which is there, the kind of new technologies that a student learn, and the kind of update in curriculum that we find in a university like Graphic Era is totally up to date. And therefore a student, when he gets out, he meets the industry standard very quickly in comparison to other disciplines where there is a long gap between what an academia is teaching and what the industry actually wants. It is a common query for computer science students whether they will be able to do well in computer science if they have not taken programming in class 12th. And the answer is yes, they will do pretty well, because in first year itself we have an introductory course to programming where we start from basics and bring a student to a very good level through programming assignments, labs and theory. So any student who doesn't have a background can also learn computer science very fast. In fact, in US you would find that people from physics or any other discipline who have done their bachelor's in physics, maths or chemistry or whatever, they come and join computer science for their masters. So it is an area where people actually begin to learn very quickly.